Wait, why did I come here? What did I want to do again?
Maybe you wanted to leave me reading peacefully. I'm sure you won't find what you search here.
Are you learning something about the brain? That's great. Consequently, are you able to explain to me why I could play Bach's Suite on the violin by heart immediately, even though I learned it 3 years ago, and on the other hand, I cannot remember the task I wanted to do 3 minutes ago?
There's a long story behind it. What I can shortly tell you is that this phenomenon has to do with our long and short-term memory, which differ in the duration of it. Short-term memory is temporary storage of information, whereas long-term memory is something you can use and recall after a very long period.
However, when are memories assigned to my long-term memory, and when do they stay in short-term memory?
Memories in general are neural pathways that are strengthened each time that we are used to recall or remember them.
You have to know that our whole body is working through electrical and chemical reactions.
So do our memories. So when something stimulates them, a chemical or electrical signal is sent over them through our brain. These nerve cells are connected in certain patterns, the synapses.
So technically, I conceived many giant mind maps in my brain that let me link all the things that trigger a certain memory or action that I learned.
Now you've created a new synapse for a specific memory. Sometimes electrical pathways are moved but still kept. And some pathways are cut off altogether so that we lose that specific memory. This change in flexibility of our brain is called neuronal plasticity. When the impulses are transferred from one cell to the other, the electrical impulse is translated into a chemical one. This causes the flow of calcium ions into the synapse, which activates recycles that release chemical messengers such as glutamate. The glutamate in turn can bind to glutamate receptors. As a result, sodium flows into the next cell and the reaction happens again. The progress of learning is long-term potentiation, which is basically the improving of the connection between the synapses, for which the receptors are important. The first glutamate receptors are the AMPA receptors through which sodium ions flow. In this way, a new impulse is caused. The second ones that increase are NMDA receptors, which receive sodium and calcium flow. This makes the impulse stronger. You can compare this process to you putting oil on your bike. It makes it run better, so you can get faster.
That means all my built memory is based on the intensity of connections in my brain. The more often I reuse a specific memory, the longer I will remember it, because new paths are forming, the surface gets bigger, and the connection intensifies. And since I only thought once about my task and didn't feel it was very important, I quickly forgot.
I think you have understood it. The process is called neuronal learning.
Oh, speaking of the task, I remember it now. I wanted to search keinem. Yeah.